Now we'll look at t-tests. Here is a little image showing Mr. T-test, showing how error bars show significance. And if one is a wide error bar, then there is no significance. So t-test compares whether two groups have different average values. So for our example was, do men or women have different average heights? So t-tests are calculated through this equation at the bottom, right here, which is x1 minus x2 divided by the square root of this. And don't worry, we'll not be calculating the t-test by hand. This is all done in SPSS. So a difference is more likely to be meaningful and real if 1, the difference between averages are large, 2, the sample sizes are large, and 3, data points are consistently close to average values and not widespread, so you have a low standard deviation. So this is a better example of what the equation would be. So the equation is signal divided by noise. So you have your differences between group means divided by the variability of groups. So your signal is what's important, and you're divided by the variability, so the differences between the groups. Whenever you're calculating a t-test by hand, you would calculate the p-value. If you calculate the t-value in this chart here, you'd go to the page, so the df is a sample size minus 1. So say you had 12 samples. So you'd go to 11, and you scroll over to find the t-value that closely matches what you calculated, and in that column will be your p-value at the top. And that's how you get your p-values in a calculated by hand t-test. So if they calculated theirs like this, and they went into it saying t equals 2.641, you'd be able to go into here, find 2.641, and go up and determine your p-value from that. So let's see if I can get a good example here. 2.641 is close to right here. So it's in one of these two columns, which would be significant. So statistical tests have assumptions that are used to inform their conclusions. So the mathematical formulas used to determine if there's a difference in your dependent variables between your independent variable groups depend on certain assumptions. So 1, the most common assumption, is that the distribution follows a normal bell curve, and 2 is that they often have equal variances. If these assumptions are violated, then you'll have mathematical conclusions to your data or choose a different test. So for instance, if the distribution wasn't a normal bell curve, you can perform a log transformation on the data. We typically won't deal with these, however. So equal variances, so variance in your groups is equal, and you'll use a Levene's test. So you don't need to memorize this, it's just an FYI. Use a Levene's test to be able to calculate the equal variances. So the variance of your groups is equal. Levene's test for equality of variances. So test hypothesis if there's no difference between variables, so p is greater than 0.05. So a and b have similar values. If p is less than 0.05, variances are unequal. So c and d have different variances. So on this chart on the side, you see that a and b have similar variances, so these bars on the graphs are similar to each other, while c and d are very different from each other and they have unequal variances. So if you look at values given by SPSS, this is a table you'd commonly see. If you go into this first orange box right here, you see a significant figure right here, and it's 0.303. This is Levene's p-value test. This means that the value, the Levene's test for equality of variances, the variances of males and females in 1910 and 1930 are equal to each other. So then you could go to the significant two-tailed test, and you look on the side where my mouse is. Equal variances are assumed because it's greater, so you use this first column significant two-tailed test value. If this was less than 0.05, you'd go to equal variances not assumed, and you go to the bottom value. Typically, these will be similar values, if not the same value. for our data at least. And this just goes into more detail about what I just said, that we have a 0.3, which is more than 0.05. So you go to equal variances assumed, the top column, they go all the way down here to the significant figure, which is your p-value right here. And this p-value is 0.04, which is less than 0.05. So how do I write the results of a t-test? Whenever you're reporting your t-test to me, especially whenever you submit your worksheets on Top Hat, I want them in this format exactly. I don't want them in any other format. There are 3 possible constructions, so replace zeros, means, plus or minus standard deviations with actual results. So 1, you have, again, replace the words as well. This one says taller, shorter. Just say live longer, live shorter, stuff like that. So 1, males, mean, plus or minus standard deviation, were significantly taller than females, mean, plus or minus standard deviation. Then it gives you t-test results in that format. Then you have females, mean, plus or minus standard deviation, were significantly shorter than males, mean, plus or minus standard deviation, t-test, t equals, p equals. So whenever you submit your values to me, please report them in this format exactly. Yes. Thank you.